All right, guys, so in this video, we're going to put all the factoring stuff together, okay? We're going to factor out a GCF, we're going to factor difference of squares, sum or difference of cubes, factor by grouping, whatever we might have to factor, it could show up here, okay? So we're going to go through these four problems and take them step by step, okay? So let's look at the first one. We've got 2x to the fourth minus 8x squared, okay? Hopefully you recognize that there's a greatest common factor there. All right, so both of those terms are divisible by 2x squared, okay? You know, we see squares here, but 2 and 8 are not squares. There's a minus sign here, so we could potentially get to difference of squares, and that's kind of the thought process you need to go through is what could potentially happen and recognizing that, okay? So once we take out that GCF, we're going to divide both these terms by that GCF, and what's left in is a binomial that hopefully you recognize by now, a difference of squares. So we want to factor that out. So we bring down our GCF, that's going to be part of our answer, and we're going to factor the difference of squares as x plus 2 and x minus 2. Okay, so that's going to be the complete factorization of this binomial here. So GCF followed by difference of squares. Okay, pause the video, try this one. Notice there's going to be a GCF here, and then you're going to factor what's left over. Okay, so pause the video, come back, check your work. All right, so the GCF is going to be x. They both have one x in common. Here, y squared and y to the 6, y squared is the factor in common. So what that's going to leave us with is x to the 4th minus y to the 4th. Okay, difference of squares here. So I'm going to bring down the xy squared. And when I factor this, I get x squared plus y squared, x squared minus y squared, okay? We had a difference of squares here, so we're going to factor that as the sum and difference of those square roots. Now, hopefully what you recognize is we're not finished. We've got another difference of squares here. So I'm going to rewrite those two. I can't factor a sum of squares. I can factor a sum of cubes, but I can't factor a sum of squares. So these two factors are just going to come down. They're going to be part of my final answer. And I'm going to factor x squared minus y squared as x plus y, x minus y. So this is the complete factorization of the binomial we started with. All right, let's look at h. I've got 4 terms. So the first thing that comes to my mind is factoring by grouping, okay? But we always look for a GCF first, all right? So this is divisible by 3. Only 3 is what they have in common. So when I divide each of these 4 terms by 3, this polynomial with 4 terms is what I'm left with, okay? So that 3 is going to be part of my answer. We're just going to carry it all the way through the problem. But now I'm going to factor this polynomial by grouping. I can't group the first 2 terms together, okay? 9xy and 49 here have nothing in common, so I can't group those together. So I've got to try something else. So I'm going to group these 2 terms together. They have an x in common. I'm going to group these 2 terms together. They have a 7 in common. And then I'm going to see what happens. Okay. Remember, when you factor by grouping, the binomial that's left after you've grouped these and then taken out a greatest common factor is it has to match up. Okay. So I'm going to group the 9xy and the negative 21x. You can see that here. Notice I've used brackets to help my separation here. And I've got negative 49 and 21y. Well, notice I flipped those around, okay? 21y was positive, it stays that way. 49 was negative, it stays that way. The reason I flipped those around is because this expression has a y in the first term, so I need to make sure those match up, okay? Again, I need my binomial to match when I factor out a GCF here and here. So, this binomial, they're both divisible by 3. They have an x in common, so we take out a 3x. Okay, so when I divide each of these by 3x, I'm left with 3y minus 7. Okay, 21y and 49, we said they had a 7 in common. When I take out that 7, I'm left with 3y minus 7. All right, well, that's fantastic because these 2 terms, these 2 binomials match up. So that means what I've done has been successful. Okay, so I'm going to bring the 3 down. I'm going to take the 3x and the 7 here, just like we learned when we were going over factoring by grouping. That's going to create my binomial here, and then the binomial that matches is going to come down to be part of my solution as well. So this is the complete factorization of this polynomial in H. Okay? All right. Pause the video, give I a try, and then come back and check your work. All right. Obviously, you see x cubed. So we've only got two terms here. So the first thing I'm thinking is this is the sum of cubes. Now, it's not currently because 54 is not a perfect cube, and neither is 128. But what I should recognize is that both these numbers are even, okay? The greatest number that these two are both divisible by is 2. So I'm going to divide both those by 2, and I'm going to hope that a difference or sum of cubes is left over. So when I divide 54x cubed by 2, I get 27x cubed. Well, that's fantastic. That's a perfect cube. Okay. 128 divided by 2 is 64. Okay. 64 is a perfect cube also. So this is great. I can factor this binomial using that pattern we learned in the previous video, the sum of cubes. Okay. So I'm going to bring the 2 down. The cube root of 27x cubed is 3x. The cube root of 64 is 4. So my binomial is going to be 3x plus 4. Okay, and again, hopefully you remember that pattern. We're going to square the 3x. We're going to multiply these two together and change the sign. And then we're going to square the 4. That's going to give me the trinomial that falls out here. Okay, so when I square 3x, I get 9x squared. When I multiply these two together, I get 12x. Change the sign, make it negative. And when I square the 4, I get 16. All right, so if you'll notice, we've got some GCFs in all 4 of these problems. We've got difference of squares once here, twice in part G. We've got factoring by grouping in H, and we've got the sum of cubes here. Okay, so there's a lot of different factoring patterns represented here. Okay, you need to know how to do all of those as we progress through this class. Factoring is a huge part of what we do.